We will solve problem 2.14 from the book Heat Transfer J.P.Holman 10th editions. Here's the statement: a wall is constructed of a section of stainless steel. Its thermal conductivity is 16 watt per meter centigrade, 4 millimeter thick, with identical layers of plastic on both sides of the steel. The overall heat transfer coefficients considering convections on both sides of the plastic is 120 watt per meter square centigrade. If the overall temperature difference across the arrangement is 60 centigrade, calculate the temperature difference across the stainless steel. So the problem is very easy, just to understand the concept what basically it says. So the thickness, so let's say this is in between, this is the stainless steel sections, and on both sides there is a plastic arrangements on one side and on other sides. So this B block is basically considering the stainless steel sections, and the C and A is the plastic that is attached on its both sides. So the thickness of the stainless steels, that is 4 millimeter, and its thermal conductivity, that is 16 watt per meter centigrade. So plastics, here is plastic A on one side, this is plastic C on the other side, and this is steel. We need to find the temperatures across the steel sections. So we need to find this temperatures difference. So that is our requirement. So Ts we need to calculate, and the overall temperature difference T infinity 1 and T infinity 2, that is provided. So the overall temperature difference is, that is T infinity 1 minus T infinity 2, and it is 60 centigrade. And also overall heat transfer coefficients, that is 120 watt per meter centigrade. So overall heat transfer coefficient, that is 120 watt per meter square centigrade. Now come to the solution. You know that the overall heat transfer coefficient is equal to 1 divided by the total resistance. In this, say I will say overall resistance. So our resistance that is offered by this plastic, then steel sections, and then this plastic. And the resistance that is offered to the heat transfer by the steel sections is equal to X divided by A. So what is X? That is thickness, that is 4 millimeters. So that is becomes 0.04 divided by K. What is the K value? That is 16. So when you divide it, you will get the resistance that was offered by steel, that is 0.025. The overall resistance from this formula you can get, that is will be equal to 1 over overall heat transfer coefficient. So it will become 1 divided by 120, and you will get 0.0833. So it is 0.00833. Now we are interested to find, the temperature difference across these steel sections. The overall temperature difference is given, but we have to find the temperature difference of this mid block. Okay, so remember, temperature difference have direct relationship with the resistance. So higher the resistance, higher the temperature difference you will observe. So the temperature difference at the steels have direct relationship with the resistance that is offered by the steel section. So this is RS. Now divide this. So we are solving this by corresponding ratio concept. Now divide this resistance with the overall heat temperature difference. So overall temperature difference, that is 60 centigrade, divided by the overall resistance. We need to find this value, so you have to arrange the formula. The temperature difference across the steel sections is equal to RS. What is RS value? It is 0.0025 divided by R overall, that is 0.00833 multiplied by the overall temperature difference, that is 60. When you simplify this on calculators, you will get the temperature difference across the steel, that is 18 centigrade. I hope you understand. If you still have any confusion, you can ask in the comment sections.